Hello students, today we are going to talk something about magnesium salt water activated battery during your lab session of engineering chemistry laboratory with the code BCHY101P. Today we are going to do a demonstration of an experiment which is very simple: magnesium salt water activated battery, which is an eco-friendly system and it can be used in any place without any requirement of electrical energy, plug points and various other things. Depending on the number of cells you are connecting in series, you can derive that much of voltage. It can light an LED lamp, it can run a small fan with a small motor, and various other things can be done for about 3 to 4 hours time. The objective of this experiment is to make an eco-friendly magnesium salt water activated battery, with magnesium being the anode material, and you can use copper, graphite or any other more electropositive element as the cathodic element, and salt water of a particular concentration, approximately 3 to 4% concentration of salt water is used for activating this battery. The idea of this is, when you go to a place where you have a seashore and you don't have any other electrical appliance available with you for lighting or something, if you carry some magnesium foil or steel in place of magnesium, we can also use steel. Nails, small nails you carry with them, some containers and some salt water and some copper pieces, you will be able to connect the cell, and if you connect more number of cells in series, you can run a small LED bulb of 6 volts or 9 volts for about 3 to 4 hours time. That is the idea of introducing this experiments for you. The materials which we are going to use here are a magnesium electrode which is fabricated in-house. You can use a magnesium rod, you can use magnesium foil, and of a particular length of magnesium foil you can cut, put it inside the salt water. You can use a copper electrode, a copper wire with the sleeve can be used. You remove the sleeve underneath and put it in the salt water solution. These two make the anode and cathode compartments. In the cell, magnesium works as anode and copper works as cathode. And you have salt water, maybe 3%, 4%, 5% or sea water directly you can use. Some plastic cups, 5-6 plastic cups you can have them, so that you can connect all the 6 cells in series. Connecting cables, while connecting cells in series you need connecting cables with alligator clips and a multimeter to measure the voltage and current or functioning of an LED bulb and various other things. Generally, magnesium is highly oxidizable material. It stays very high in the electrochemical series, much above hydrogen. So, magnesium can easily be oxidized to magnesium 2 plus with the release of 2 electrons. This is the anodic half cell reaction. The cathodic half cell reaction is copper wants to get reduced, so it picks up the 2 electrons released by magnesium. Copper picks up these 2 electrons and becomes metallic copper. This is the cathodic half cell reaction. Now you see the picture, you are putting simply one magnesium rod or foil and you are putting a copper cable or copper rod inside this. You put approximately 3%, 4% sodium chloride solution. You don't have to use iodized salt or purified salt and all that. Normal crystal salt is more than adequate. Even if it has got some impurities, it doesn't matter. You put the solution inside this, make the magnesium electrode and copper electrode dip completely in the electrolyte solution, and if you measure the voltage will be anywhere between 1.4 to 1.5 volts, 1.4, 1.45, 1.5 depending on variation in concentration of sodium chloride solution. Now, why these reactions happen? Magnesium and copper are considered to be 2 dissimilar metals in the electrochemical series. Dissimilar metal means they stay away in their electrode potentials from each other. When you have any 2 metals staying away by more than 200 millivolts in the electrochemical series, you can form a galvanic couple. That is the principle used here also. So, magnesium and copper form a galvanic couple, and the electrolyte which activates the whole cell is just sodium chloride solution. So magnesium gets oxidized and copper gets reduced, like I talked to you in the equation. Now when you want more voltage, suppose you want to light an LED bulb of 6 volts, you connect 6 cells in series. You will get 1.5 into 6, approximately 9 volts or 7 volts or 8 volts you will get. But one thing is, as the time is progressing, magnesium gets consumed and the voltage will drop down, and after 4 or 5 hours the magnesium voltage will come to very, very low levels where you cannot light LED bulb or anything else. Now after you have done this, what we are going to demonstrate now is, we are going to have 6 cells. We are going to measure the individual voltage of all the 6 cells, record the voltage of those 6 cells, and then connect all the 6 cells in series. That means magnesium to copper, copper to magnesium, like that we will connect them in series. I think you people should be familiar with connection in series. When you do that in series, you measure the voltage will be added up for all the 6 cells, and that is the voltage which you can use for lighting an LED bulb or a fan. Now I am going to demonstrate to you the simple construction of the magnesium copper cell. What we have done is, we have taken a magnesium foil, we have inserted in a glass tube, and we have taken it out from the other side, we have fixed it to a plastic lid. Same way, we have taken a thick copper wire, we have put it in a glass tube, sealed on both sides, and we have taken out the copper wire for electrical connection. This is the electrode assembly. 6 such cells have been made, 6 such assemblies have been made, and this plastic container contains salt water which is around 3%. That means 3 grams of crystal salt in 100 ml of water. Like this, we have 6 plastic cups which are positioned here. Now I will show you how we are going to measure the voltage. Now we are going to fix the 2 electrodes in a particular plastic container containing 3% sodium chloride solution. We have a multimeter which can measure voltage of individual cell. As you can see, when I am measuring the voltage of this cell, it is showing nearly 1.4 volts. Like this, we will measure the voltage of each one of the cells that is present here. I will make the connection more proper so that we will have proper voltage readings coming out of that. You see, the voltage of cell has gone up to 1.582. What I have written there as 1.4, 1.45 is a nominal voltage. Depending on the conductivity of the electrolyte, the voltage may slightly vary. Now every cell we will measure the voltage like this. I have done connection for the next cell which is showing 1.468. So like this, each one of these cells is going to show you a voltage of 1.45 to 1.5. Now what we will do in the next step is, we will try to light a small LED bulb with all the 6 cells connected in series. I will tell you how we are going to do that. Now we have 6 cells here. Now what we have done is, this is the beginning cell, cell number 1, 2, 3, 4, 5, 6. We have connected this magnesium, this copper to this magnesium, this copper to this magnesium, this copper to this magnesium, and like that we have connected. Now we have 2 terminals left out. One is copper, another one is magnesium. Now we will measure the voltage of this cell. The 6 cells which are connected in series, we will measure the voltage of all these 6 cells together. Now you see what is the voltage you are getting? You are getting 8.84 volts because all the cells are connected in series. If you want to get more voltage, you can have another 4 cells, another 5 cells in series. Depending on the number of cells, you will get 1.4 to 1.5 volts more for each cell that you are connecting in series. Now ultimately this has to be used for some application. Right. Now I have connected one 6 volt LED bulb. I will just show you. When I remove the connection, the bulb is off. When I put on the connection, the bulb is on. So this is a 6 volt LED bulb. It is able to switch on by connecting these cells in series. This will run for nearly 3 to 4 hours uninterrupted. Once the voltage of each cell falls down, that is when magnesium is getting consumed, then the voltage will fall down, and when the voltage comes to below 1.2 volts, the light will stop. And you can also run a small fan with a small motor. These are all things which are used in small dolls and other gadgets for cooling purposes. It can be done, and if you want to charge a mobile phone, you connect more number of cells in series and have the adapter. You put all the wires in the final 2 wires in the adapter, connect it to a mobile phone. The mobile phone also will get charged for some time. So this is precisely the experiment which we are going to do when you come to the lab during this semester or during the next semester. Now what we are going to do is, after we have done the experiment completely, we are going to use this table. We are going to write the voltage of each one of these cells, and we are going to write the voltage of 6 cells when they are connected in series. If you want, you can do this experiment using jump clips, small nails which are long enough, and use copper or graphite as a counter electrode. Put them in salt water, you will get voltage there also. But the voltage with magnesium is the highest because it is very high on the oxidation side. If you use steel, nail or crocodile clip or something else, they will also give you voltage which is much less. If this is giving 1.4 to 1.5 volts, they will give about 0.7, 0.8 volts per cell. You need more number of cells to be connected in series. This is precisely the experiment which you are going to do.